Good morning. Our today's point is derivations of the physical quantities which are required to describe the linear SHM. Suppose that this is a linear SHM of a body. Then we know that this is an important phenomenon, and the study of physics means it's a description by using physical quantities. So we know that first physical quantity is displacement, then velocity and acceleration. So for the description, the sequence of the quantities used is displacement, velocity and acceleration. But in case of derivation, if we want to derive the expressions for these quantities, then the sequence is reversed, like acceleration, velocity and then displacement. So write down our today's point, and it is starts with acceleration, acceleration, acceleration in bracket small a comma velocity in bracket small v, and the next point is displacement, displacement in bracket small x, and the sequence is reversed. Instead of displacement, first quantity is acceleration, because we are going to derive expression for these quantities. So write down the question, and this question is important question, so denote it as VVIMP question. And we already know that this question is derive expressions for derive expressions for acceleration, comma velocity and displacement in linear SHM. This is our today's question. Derive expressions for acceleration, velocity and displacement in linear SHM. Let us see first what are the steps of this derivation. Here we are going to use a differential equation. From differential equation we first separate acceleration, and from acceleration we are going to separate velocity and then displacement. So instead of our general 4 points consideration, diagram, notations, here this is a mathematical part only, and so write down directly the differential equation of linear SHM is, we know that the equation d2x divided by dt square is plus omega square x is equal to 0. We know that this is our differential equation, but from this we are going to separate acceleration, and therefore here d2x divided by dt square is equal to minus omega square x. Write down this as equation number 2. We know that this is acceleration, but here we are going to derive it and know it how this step becomes acceleration. So if x is if x is the displacement, if x is the displacement in linear SHM, if x is the displacement in linear SHM, then velocity and acceleration are velocity and acceleration are expressed here. Velocity is equal to dx divided by dt, and therefore acceleration is equal to dv divided by dt is equal to d dt of dx divided by dt. Write down d dt of dx divided by dt. d dt of dx divided by dt means there is a double derivative of x with respect to time. So acceleration become d2 x divided by dt square. Denote it as equation number 2. And therefore from equation 1 and 2 we get acceleration a is equal to minus omega square x. So write down from equation 1 and 2 we get from equation 1 and 2 we get a is equal to minus omega square x. This is our equation 3, and this is the first important equation. Denote it as a star. Write down this is an expression. This is an expression for acceleration. This is an expression for acceleration in linear SHM. In linear SHM. After the acceleration, our next point is velocity. So write down expression for velocity. Expression for velocity. Here we are going to use above formula for the velocity. So using a is equal to dv divided by dt. Using a is equal to dv divided by dt in equation 3. In equation 3 we get. In equation 3. This is the important step. So denote it as a star point. And therefore dv divided by dt is equal to minus omega square x. Now we are going to separate v from dv by integrating, by integration. And therefore in order to give the element to x, our next step is also important step. So here this important step is, it seems to be simple step, but it is very important, and it is a multiplication of dx by dx means only multiplication of 1. So due to that, this multiplication, there is no change in this equation, but it is useful step. and so denote it as a star step. And therefore here dx divided by dt. Rearrange these terms. Dx divided by dt into dv is equal to minus omega square x into dx. We only rearrange these steps. And therefore, integrating above equation we get. Therefore, integrating above equation. Therefore, integrating above equation we get. Therefore, integrating above equation we get. Here dx divided by dt means velocity. So v into dv, integration of v into dv into integration of minus omega square x into dx. So let us solve this integration. We know that integration of x is x square by 2. Similarly, integration of v is v square by 2. So solve these integrations here. Solve these integrations. Integration of v is v square by 2 minus omega square into x square divided by 2 plus c. Denote it as next equation number 4. This is the integration of the above equation, where c is a constant. Write down where c is constant, where c is the constant of integration, because we don't know from which point to where we are going to integrate, and so the constant arises in this point. Is the constant of integration, and which can be obtained by using conditions at extreme point. Using conditions at extreme point. We know that at extreme point, point x is equal to a. Here denote a as amplitude plus a, and x is equal to and v is equal to 0. Use this in equation conditions at extreme point. At extreme point x in equation 4. In equation 4. Using conditions at extreme point. At extreme point x is equal to a and v is equal to 0 in equation 4. And therefore here 0 is equal to minus omega square a square by 2 plus c. And therefore c is equal to omega square a square divided by 2. Denote it as equation number 5. Denote it as equation number 5. And therefore using equation 5 in 4 we get v square divided by 2 is equal to minus omega square x square divided by 2 plus omega square a square divided by 2. Now here omega square divided by 2 is a common, and so here is a square minus x square, and therefore 2 becomes cancelled, and so therefore v square is equal to omega square into a square minus x square. And therefore v is equal to plus minus omega into square root of a square minus x square, denoted as equation number 2, and highlight this equation. This is a velocity in SHM. Right here, this is velocity. This is velocity in SHM. In this way, we derive velocity from the expression of acceleration. From expression of velocity, we are going to derive expression for displacement in linear SHM. So, write down or denote this point as expression for velocity. Expression for, displacement. Expression for displacement in bracket x. Now, we know that this expression can be determined or derived by using expression of velocity. And here, the important step is we are going to use the magnitude of velocity. So write down. From equation 6, the magnitude of, the word magnitude is important. The magnitude of velocity, is, we know that expression for velocity in equation 6 is v is equal to plus minus omega into square root of a square minus x square. Here, if we are going to use magnitude, then there is no sign, plus and minus. So write down the equation. V is equal to omega into square root of a square minus x square, denoted as equation number 7. We know that, but, or write down, but v is equal to dx divided by dt, or write down using v is equal to dx by dt in equation 7, we get dx divided by dt is equal to omega into square root of a square minus x square. Now separate the terms of x and time, and therefore here the term is dx divided by square root of a square minus x square, write down this, is equal to omega into dt, is equal to omega into dt. Now integrating above equation, we get, therefore integrating above equation, we get integration of dx divided by square root of a square minus x square is equal to integration of omega into dt. Solve this integration. After solving, above equation, we get sine inverse of x divided by capital A is equal to omega into t plus alpha, where alpha is the constant of integration, and therefore here we get x is equal to x upon a is equal to sine of omega t plus alpha, and therefore x is equal to capital A into sine of omega t plus alpha. This is our equation number 8. This is equation of displacement or general equation of SHM or linear SHM, or general equation of linear SHM. If it is important, if the particle starts from any point, if the particle is performing, suppose that this is a particle and it is performing linear SHM, then in the path AB it may be start from any point. If the particle starts from any point, then this is a equation and it is called as a general equation of linear SHM. So write down the case first. If the particle starts from mean point, if the particle starts from mean point, then at t is equal to 0, the x is also equal to 0, and using this in above equation we get, therefore using in general equation we get, using this, write down, using this in general equation we get use it in general equation. Here 0, then a into a sine of 0 plus alpha, and therefore sine of alpha is equal to 0, and therefore alpha is equal to 0 or pi by 0 or pi, 0 or pi, write down 0 or pi, sine 0, 0, therefore alpha must be equal to 0 or write down 0, alpha is equal to 0, and therefore x is equal to plus minus a into sine of omega t, denote it as equation number 9. This is a displacement if the particle starts from mean point. This is displacement in SHM. SHM the particle if the particle starts from mean point, it is already, if the particle starts from mean point, and the case second is if the particle starts from extreme point, if the particle starts from extreme point, then at t is equal to 0, the x is equal to plus minus a. X is equal to plus minus a. And therefore, using it in general equation, we get plus minus a is equal to plus minus a into a sine of 0 plus alpha. Instead of phi, I use here alpha. You can use here phi instead of alpha. And therefore, 1 is equal to sine of alpha, and therefore alpha is equal to pi by 2 or 3 pi by 2, and therefore x is equal to plus minus a into sine of omega t plus pi by 2, and here it becomes a into a cos of omega t, because sine of theta plus pi by 2 is equal to cos theta. Denote it as equation number next. This is a displacement if the particle, this is displacement if particle starts from extreme point. If the particle starts from extreme point. Now, the additional point is expressions for displacement, velocity and acceleration. Write down. This is additional point. Expressions for displacement, velocity and acceleration in linear SHM. Write down this point. Expressions for displacement, velocity and acceleration in linear SHM. First, x is equal to, in magnitude here, first x is equal to a into a sine of omega t plus alpha or phi. Write down here alpha. We can use alpha or phi, and therefore v is equal to dx divided by dt, and so our next, don't denote it 1, 2, 3. Therefore v is equal to d dt of a into sine of omega t plus phi. Denote it as a square bracket for our simplicity, and the derivative of this is becomes a omega into cos of omega t plus phi. Denote it as equation number A because it is an additional point. This is displacement, this is a velocity, and therefore acceleration is equal to dv divided by dt is equal to d dt of this derivative, a omega into cos of omega t plus phi, and so the acceleration becomes minus a omega square into sine of omega t plus phi. Denote it. Only we are going to use equation, so don't denote as a numbers.